Hi students, AI and design. How was yesterday's topic? The first programming coding environment. I know some of you already have experiences in that kind of things, computer programming, web-based coding, whatever, Python, C++, Java. But I believe most of you are totally new to that kind of computing and computational development environment. But in this class, as I mentioned before, and also described in the course syllabus and the planning, AI and design doesn't mean to train you are going to be being an expert in computer programming or something, or just designers or something. How to make synergy, how to make 1 + 1 not just 2, it could be 3 or 4. You have your own domain knowledge, domain interests, wherever you are. You are in someone from design domain, someone from economics, someone from management, administration, someone from some other type of engineering, science, whatever. And I provide you very minimal weight, yet really powerful resource in computing. That computing, cutting-edge computing, was in this class AI, artificial intelligence. So that is why I am bringing your attention to encourage you to use that kind of web app, easy to use yet powerful things such as TensorFlow, Google Colab-based development, and so on. So we walk through some kind of general aspects of them. What to do? The first representative thing is here, today's topic, image recognition. You can train your own images such as, how about your handwriting, your entire handwriting, this kind of numbers or alphabets, English, or your own mother tongue language, whatever it is, it could be trained and recognizable by your own machine. So that whenever your new handwriting given to computer as an input, computer will be answering, okay, what is this? What's this? What's the meaning of your input writing? Something like that. Okay. Actually, this is so-called some technology on the bookshelf. It's available nowadays, almost everywhere. Your Facebook, Instagram app already adapted that kind of image recognition technologies. Whenever you park your car, some parking system recognizes your plate, your numbers, characters on your plate. They can be recognized and stored in your database so that make some kind of parking fee calculation or something. So anyway, very representative image recognition technique is the main and the first subject you are going to do. And don't forget, according to the schedule, we are here, image recognition, AI exercise number 2 will be given today. And you have to submit your own output following the instruction from the exercise and submit your turn-in until due date. Okay, and then we are going to move to some other image recognition related things and some data science things, text learning things, and so on. And then so far I give you some given subject. For example, dog face, cat's face recognition, or very general purpose image things, or my own domain things such as Starbucks, Blue Bottle, interior design, pictures, training, or something like that. But you can build your own input data for training data, and you can perform your own training model and anticipate your own new result. That's going to be another contribution in this AI domain so far we developed. Okay, anyway, seeing is believing, so let's move on. Take a look, image recognition, but actually image recognition is very common technology, right? Why I'm saying this is common technology? let's take a look our smartphones. As you know, your friends, your family, by names or even without names, they automatically classified in your smartphone. When you take your selfies or your friends' pictures, your dog, cats, anyway, among some kind of several people's pictures, the smartphones can classify your portraits something like this way. Okay, this is sort of common technology we are using in our smartphone or some kind of computing tools. How about Google's? You know, Google, when I was an undergraduate student, Google firstly introduced to people. At the time, I supposed to buy their stocks or something, but anyway, fortunately, I got email address they made, Gmail. So that's why my email address is Kook at Yonsei University, as well as this one. Someone sent email for asking something about classes or something. Anyway, this is my Gmail account. In the same way, Yonsei. Actually, Yonsei University email system also Gmail system. Around 2 years ago, we integrated our Yonsei University email system to gmail.com, the same as other universities' email system. Probably your school emails also some of the Gmail account. Anyway, fortunately, I use my full name to Gmail at the time. Before studies abroad at the time, so I put my last name at first. It's Korean style name sequence, right? But anyway, my point is, Google has its own history and really good advances in computing domain. So whatever you search by Google using your own keyword, very advanced technology, you know that, right? If you type cat, you can find out amount of cat images. If you search some dog images, and then you Google's display amount of dog images and related something, right? That's really strange, isn't it? Have you thought about why they can do that? How Google can classify those images for your better image search result? Let's quickly look at this mechanism. What if there is an image representing some flowers or something else, right? Something like this. Anyway, this is a picture, probably JPG file or GIF file, PNG file, whatever. This picture has sort of metadata, which contains date, time, for when someone took this picture, automatically the camera, digital camera, insert this one, right? And some other index data or some kind of camera data. For example, this image includes something about camera, the camera model, brands, and the focal distance of the lens when they took this picture, something like that, and some modification history, modified data, which means the last edited this image is when, the date and time, or so, something like that. Something like this very technical data already included in this data. But you know what? These are something computer related data. But by human being, what we need? We need, of course, this one, date and time, something. And who took this picture? When also included in here, but where? Actually, if the camera has GPS data, which means well, also included in this picture. But to human being, GPS data is altitude, longitude, some kind of numbers. They need something like this. My friend's home, my friend's dormitory, or somewhere in some street, on my campus, main gate, or the study room, or my friend's birthday party, something like that kind of information. Who, where, or also why, okay? Why here included? For example, my friend's birthday party, something like that, okay? And also some additional information. I'm sorry, this is not good. Anyway, some information we need is something exclusive in this image. So how we put this information, how we put this data, text data, textual data, that is so-called tag, okay? So when we put some kind of text, for example, your hashtag, when you upload your picture to Instagram or Facebook, you can place some kind of hashtag, okay? Something like this, my dog, or my friend Jamie, something like that, okay? Anyway, these are tags, and technically they are all text data. So when you search Google, or even your hard drive, when you when you search Google or your hard drive search, what you type in, of course, your friend's name, okay, my friend Anne, birthday party, something like that, okay? So based upon your input, this is your input. Computer search only this part. Sorry, why this is moving? This part, and you placed your friend's name here. So this one can find out your friend name and birthday. So birthday party, somewhere here, the database or data system, this one can find out birthday party or something like that, your friend. And also this one, Google knows your account. So when you say my, and then this one understands your account. If your account name is my name, Kook Lee, Lizin Kook, and then my friend, which means Google understands, okay, account, Google account, this IDs, friends, something like that, okay? And then Google can show you appropriate results based upon those textual data input, right? This is your input, and this is the data set. Input gonna search based upon your data set, as well as this one also included here, okay? And then results can be seen like this way, okay? But this is actually a very conventional approach to image search, right? When you use Google or your hard drive, you are searching by your own text input, like my picture or my friend someone or anything else, right? That's sort of the existing current technology we use so far. Let me clean up this image and let's take a look at something advanced part. Here is an image, right? Sorry for ugly image input. Anyway, here is an image, and the metadata, I told you, something computer generated metadata is here. This is computer made, computer generated, and also some kind of textual data. So where this data from? User made, right? User, for example, hashtag text or some, how about the image file name? You usually name your image. For example, my final project result, project presentation 1, something like that. .jpg, something like that, okay? Or some kind of title. When you post this one on top of the some Instagram or some other website, you put some title text. For example, my friend, someone, birthday party or graduation, something like that, okay? Celebrating something, whatever, okay? Some kind of user-made textual data can be sort of the data source for searching, right? So far, this is existing technology and very common. And Google image search or your hard drive search, input text is here. So this input text can sort of query. This is the query, okay? Query means you type certain type of input text so that you can find out from amount of images or some existing data. That is so-called database, image database or textual database, something. But anyway, whatever it is, this is something existing, your data, files, whatever. Among those data, you need to query something using something keyword, and then you need to get your own result. You are expecting very good result, exactly what you want to find out. If that result meet the requirement, your query, you're gonna be happy, right? And then you're gonna use this one for whatever. So existing data here, but what's the something intelligent part here? Actually, these are intelligent enough, actually. But nowadays, thanks to deep learning, this image consists of amount of pixels. Pixel is an atomic unit for representing this kind of 2D images, JPG images, right? So how many pixels? When you say the resolution, for example, high definition image, this is the resolution. High definition image usually 1920 by 1080. So when we say HD, full HD, that's 180p image. What is 180p and what's the meaning of P? P means pixel, okay? So what is 1080? The height is 1080 pixels, okay? 1080 pixels here. If we place numbers, going to be 0 to 1079, okay? That's the number in y-axis. How about x-axis here, 1920, close to 2000, right? This is 1920, 1920 pixels. In x-axis, right? That is so-called resolution. This kind of 2D images resolution. Okay, why I'm saying this one? This is sort of very common specification and sort of knowledge when you look at some HD TVs or your monitors. When you buy your laptop, my laptop has full HD, which means 1920 by 1080 pixels in your front screen. When you buy your laptop is looking like this, right? So the x-axis, y-axis, its resolution is here. If you buy full HD, regular laptops have this kind of resolution. But how about the MacBook Pro? Very expensive, cutting edge, technology based, expensive, high-end users. For high-end users, expensive laptops. They have sort of something like it. Something like this resolution. The number's probably wrong, but anyway, even more pixels compared to full HD. But anyway, the reason for saying this one is, okay, computers, metadata, also texture data, and users' texture input, also texture data, but they need to compute the pixels one by one. So how many pixels? Result for this one, okay? I'm not sure how many, but around some millions of pixels in this picture, one single picture. So computers read one pixel by one pixel from top left to bottom right. So read one pixel by one pixel, something like this, until the last pixels. And then your screen, your laptop can visualize your JPG file input. That's very easy to say representation of the mechanism of computer visualization on top of your computer screen, your laptop screen, okay? So this is so far never used for this kind of user search or some kind of query or something. But thanks to deep learning and some other machine learning technologies, this pixel data can be represented in, sorry, why this is moving, layers. So when this application, deep learning application, build its own layers from this input, as I introduced you before, when we are dealing with some deep learning things, some point layers, edges layers, and their polygon shaped layers, okay, and some kind of additional shape layer and something object layer, something like that. So this is sort of a simplified version to show you what are layers in deep neural network in the mechanism used in deep learning. So based upon these layers, this one can simply say can find out some kind of patterns. Of course, these patterns in computer storage, they are all numeric data, not shape data or some kind of visualization, image data or something. But the point is, originally it's an image, but into computers, that's numeric data, so-called something similar to patterns, okay? So cat's pattern, dog's pattern, they are different to computers. Anyway, anyhow, computers figured out what the pattern for cat pictures, what is the pattern for dog pictures, what is the pattern for my daddy portrait, what is the pattern for my mommy's face, something like that. And then at least here put some texture data, okay, textual input, some more info. And then these are existing data, okay. Let me use this one, okay. This part, something existing data computer used so far. And this part is sort of newly established data. We can call it some artificial intelligence, okay. This is so-called AI related data. Of course, this is intelligent enough. This one also intelligent. What if we don't have such data, texture data? We have only images. The computers, the reason to use computer is just open JPG file and see that and translate by your brain. That's it. Computer's role is simply just monitoring, visualizing. That's it. no additional things computers can do. But thanks to this metadata, textual data, user input data, this is enough intelligent, okay? That's what we believed. We used to be believed this is intelligent. But nowadays, how smartphones understand this picture is your daddy, your mommy, your friend, your sister, your brother, your friends. This is cat, this is a dog. Because computer has something process. In technical taxonomy, this is sort of pre-processing or some behind processing, image processing. Whatever it is, thanks to this processing, computers has additional data, something like this, okay? This is so-called AI related data. I don't know this is good term or not, but the point is, this is the appended data from existing data, and then we can query the data. At first, this one, next phase, we can query this one in automation, and then much better result we can find out, something like this, okay? Better result thanks to this AI data, so-called AI data, okay? This is the sort of quick explanation about how that kind of common technology, something image recognition technologies used. Actually, there are something more. I told you how to process this image pixel by pixel to deep learning neural network layers and finding patterns and automatically place text, okay? Your father, your daddy, your friend, your mommy, your sister images, something like that. This is the text data, can be some kind of text data, and this kind of textual information also can be modified, upgraded by this kind of process and so on. So anyway, technically we are using this textual data, not the image data directly. The result is here, process is here, result is here, and some kind of modified result can be anyway placed in text. So user input gonna use this textual data, and result going to be from this textual data, but anyway, these are your result from this computer, okay? Actually, this technology is kind of couple of years, no, 5-6 years ago, Google already embedded this technology, which means this is sort of also common technology, not totally new technology or something. Of course, there are someone even advanced from this one. So let me quickly search. What if I search using my input text cat? This one already knows what I'm intended for searching using my keyword, something like this. If I type dog, of course, Google result shows you dog result. You know, if I click this, and if I use image search by Google, Google's gonna use that image as your input, something like that. Take a look. It's strange. Google, what I did was simply click right button and Google image search using this image. I didn't type anything, right? But take a look, the search bar here. What is this one? The image that I used for image search. I didn't type anything, but take a look. Old and young dog. This is auto-generated Google's input. Wow, this is really, really powerful and intelligent technology. We already use this one in our daily life by using your smartphone, my laptop computer like this way. But anyway, Google knows the meaning of this picture, old and young dog. And take a look at the result. More than 1,000 results are here. And this one shows you something related web pages for this image. And also this one, Google finds out exactly where this image come from. So this is something very typical, because I used some good dog and cat metaphor for your collab, Google Collaboratory experiment and exercises. What if you took your own picture or something? What if you took your selfie, your portrait? Have you tried to search by using your portrait on Google's search? Probably Google knows who you are and then displayed your Instagram or Facebook, something like that. It's something relevant to privacy issues, but anyway, the point is probably Google may display someone who similar to your face or something. But there is something high-level technology, I mean, not that domain-specific. What if you search something, let me search at this time using something like this, Chinese style interior design. And then Google knows what's the Chinese style. As you know, Instagram pictures, photos available to Google, or some Pinterest image. Okay, here is Pinterest, pinterest.com. Pinterest also very, very popular especially to designers. On the Pinterest, you can classify your own design interest and then find out something like this. So if you open Pinterest.com, you can put your category. For example, if you're interested in interior design, this one may show you very nicely generated interior design or something. If you're interested in young women's fashion design, and then this one will show you. If you're interested in gardening, this one shows you amount of plant and gardening related decoration images. If you're interested in some kind of food or cooking, this one shows you relevant images, mostly by professionals or professional-like amateurs. Very, very good pictures. This is really good website for designers and someone who likes some visual images. Okay, you know this website and Pinterest app probably on your smartphone. Anyway, this level of domain knowledge implemented in Google system nowadays. And take a look: house, restaurant, apartment, contemporary, traditional Chinese, modern Chinese. Now Google knows this kind of specifics. But a couple of years ago, this was not that intelligent in this way. What if you imagine next year or 2 years, 3 years from now, and then probably you can search a short hair young ladies talking in Chinese style living room with dogs or cats, or some details, some specifics about their pets, something like this, with bulldogs or Chihuahua dogs, something like that. And then Google's gonna find out exactly what you described by this text. And then very specified and specialized query going to be successfully find out your exactly what you want, the image what you want. So that level of advancement is ongoing nowadays. You know what? When I teach, this is not design studio class, but usually in my department, I teach design studio, digital design studio, or digital design media class. In that studio, around 2-3 years ago, this level, Chinese style interior, this one won't work at the time. Google's search result, not that good, bad, okay? Something Western design style or Japanese, Korean style, also mixed up. But take a look, nowadays, this one very specialized. Even modern, traditional, Google knows what is modern Chinese style interior. Something like this. It's really, really amazing advancement. Okay, so I quickly introduce you how Google's what this kind of advances AI-based technologies used compared to this one. This is sort of former technology, and this is current technology. But you know what? This AI part is growing. Even advanced AI features appended on top of this part. So, as I quickly show you in this example, I searched Chinese style interior, and this one plays a lot. And how about this one? What if I click Chinese style modern kitchen? Or if I turn off modern and click kitchen cabinet, among Chinese style interior, kitchen and kitchen cabinets going to be displayed, something like this. This is really, really amazing technology, okay, in the perspective of development, technical aspect. What we need is, we need to figure out, we need to know this kind of technologies are available and how to adjust, how to use, how to take maximum advantage of this thing. That's exactly what we need for in the perspective of AI and design, AID. Okay, that's the point. Sorry for sorry for this kind of mess. Notes are in mess, but hopefully this comparison between the former one and the current one, when you are using sort of common AI-based image search technology in Google or your computer hard drive. So let's take a look at some slides, how image recognition works. Actually, we need to find out some mechanism behind the technologies, algorithms. Instead, we have looked certain type of supervised learning we used. How supervised? We put tags, right? But actually not tag. We give them, we feed just input, but anyway, textual input, text input, using hashtag, title, descriptions, and so on. So these are sort of the tag for supervised learning. So computers learn by itself, so computers can figure out this is cat image, not dog image or something. Okay, so training a model. So Google search engine has a huge scale of, super huge scale of training model for images. It's growing day by day. Okay, so that's why Google search engine getting intelligent, more intelligence day by day. Okay, so labeled, tagged, going to be used for supervised learning. So when you upload your pictures, when you put some replies, text, or some comments on your images, your friend pictures, that's the sort of training process. Training what? Training Google's AI machine. Okay. So in a layer level, because this is deep neural network, the convolutional neural network, CNN, deep learning algorithm in the perspective of algorithms, take a look. Those several different images have different layers, different objects, different components. So the majority of the detection results can be displayed like this way. So this one is leopard, not jaguar or Egyptian cat or something. This is motor scooter, not bumper car or something. Because in stochastic approach, this one has the majority output numbers from analyzing this image in this kind of deep layered network, so-called the CNN. Okay, so this is sort of intrinsic behind the technology we have for this learning. But originally, around 2012, there is so-called ImageNet. This is sort of Google, Stanford, and some other universities, research organizations, some scientists in computer vision, computer science scientists competition, international competition. The objective of competition, ImageNet competition, is simple. Find out better algorithm for training images and figuring out the images. Okay, in 2012, deep learning based algorithm won this competition. That is why deep learning's sort of debut on this industry and academia is 2012 around. Okay, so this ImageNet got something breakthrough. Why they call it breakthrough? Before deep learning, the accuracy, if they draw accuracy graph, this is accuracy graph, okay, take a look. This is probably 2009, 2007, 8, and 2010, and 2011. But in 2012, this one dramatically changed like this way, going up, okay? This is probably 100%, and this is time. So what happened in 2012? That's deep learning introduced to this domain. That is why they say, okay, deep learning in image recognition, image detection, that is a huge breakthrough, okay? So around 8 years ago from now, people in this domain, in this computer science, deep learning, or artificial intelligence area, try to find out another breakthrough. But the best way to take this technology's advantage is simply adopting deep learning mechanism, deep learning algorithm. So since then, since 2012, amount of researchers are sort of all in to deep learning research, and their outputs all around, okay? So that's why I introduce you this one, okay? ImageNet Large Scale Visual Recognition Challenge. This is one of the international competition. So nowadays, if you use Google Cloud Vision AI, it's sort of API, application protocol interface. If you want to develop something not from scratch, from Google's existing AI, you can use this one. The similar to you use AI Hub or Google Collaboratory or some other APIs. What if you are trying to make a map system? You need to measure your town, your home, your city, your country, this planet. How to measure this planet by yourself? You don't need to. Instead, we can bring existing resource from Google Map, and you can add your service, yours. For example, if you want to see your drone's movement, your drone, Google doesn't know which one is your drone or something, but you know, so you put this additional data on top of Google Map using Google Maps API. So now you have your own app to show you where's your drone, where's your car, where's your mommy, something like that. Okay, this is the way how to use this kind of existing APIs. Anyway, thanks to Google Cloud Vision AI, we can nowadays we can use this one, image recognition function. Take a look. This one result, the furniture. Of course, it's furniture and it's a couch. It's in living room. It's color black. This is a room, not outdoor or something. Sofa bed, something. Interior design, of course, not exterior design or something. Anyway, the point is, thanks to image recognition technology behind the technologies, the question is how to take it, how to take advantages from Google's sort of image training algorithm. Formerly, yesterday, you have trained your own model. That model only knows whether this is cat or dog from scratch. Okay, you trained thousands of cat images and another thousands of dog images. For complicated design task, of course, we have to figure out one by one. At the end, we can make some general AI for interior design or general AI for any type of design, but we are sort of intermediate, ongoing process, middle of the process, especially very initial stage of design with AI. That is why we are handling this AI and design class, okay? So the point is, using this kind of existing API, existing Google Cloud Vision AI, this one knows furniture, couch, living room, black. But you can append more information on top of this one. What kind of information? Okay, this is modern style. And this is sort of linear style. And also this is my favorite style, something like that. And Susan's living room style, something like that kind of keyword or additional information can be appended on top of this one. So this is sort of domain knowledge area. This is general knowledge area. In the future, probably Google's gonna put more things in this area. But so far, what we need to do is we have to focus on this part, okay? Additional information, additional data. Okay, this part. Something appended on top of existing Google's API, Facebook API, or some Tesla's in AI engine, whatever, it doesn't matter. We need to take advantages from existing one. For what? For your own domain purposed things to do, okay? That's my point. Application example of image recognition. Inception version 3. This is one of the very famous and common algorithm in image recognition. So by using this one, there are amount of applications generated. For example, take a look. This is a panda, giant panda image. That's it. No descriptions, no text, no hashtag, no title, no additional textual data. But thanks to this training model, done by Inception version 3 engine or something similar, APIs, applications. Simply, this is an AI app for image recognition. This one generates those text. Take a look. Score means chance, probability, 88%. Giant panda, panda bear, something like that, okay? These are additional text data from this given image. So what we need to do is use this use text data. For what? For your own design purpose, specific purposes, or some marketing purposes, or some file restoring, or any type of your new service or new application you planned possible. So we don't need to take care about this part. This one evolves by itself. This one developing day by day, thanks to amount of genius computer programmers or researchers. What we need to do is, which data we're going to use for domain specific purposes. That's the important thing I always put another emphasis on, okay? So this is also one of the output results. As you saw in Google Colab with TensorFlow library example, detecting cat and dog example, this is Python code. I told you we don't need to learn Python, but if you read and write Python language, even if in novice programmer level, that's totally fine. Instead, you will get really huge power you never had before, okay? That's the point. So, computers only knows this kind of textual data, numbers, inside of the computers. But result pattern can be found some kind of patterns, so that this one can tell you some additional information, additional data. Okay, that's the point. So even if the image has dog and cat altogether, no problem. Computers can subdivide images like this way, and this part dog, this part cat, no problem. Okay, this is one of the applications in this domain, this area, okay? Next thing I like to quickly show you is object detection. So far, we object classification here, actually something classify input images to one of cat image or dog image as you exercise, got an exercise lecture video. And today's exercise also shows you some additional things, design style or modern style, Eastern style, Western style, something like that. But also object detection is very critical part. Take a look. In this picture, there is a person, there is a kite, and so on. And this is actually the ocean. I don't know why the color is something like this. Anyway, in TensorFlow, ImageNet or Inception version 3, whatever, certain type of existing training model. What kind of training? Image training model, okay? How to use that? Image training, we saw the cat and dog image classification, but what if the image can be subdivided in this kind of grid, and in this grid we can take one person, but in the perspective of entire picture there are many people, and this is one of the person in this image, and this is one of the object, okay, something like that. So object detection is sort of application from this image training model. As you see, this kind of grid system can detect several different objects displayed in single picture. That's the way to use object detection. So why this is critical? Tesla autopilot. You know NOAA, NOA, navigation on autopilot. Even though we saw some news accidents because of that NOAA, navigation on autopilot, we're gonna talk about this one in later class. When we are in the criticisms in AI technologies. There are many accidents, but we upgrades this kind of some flaws, errors. So somebody tells this is really, really dangerous technology, but most people believed in mature level of development we reach, and then this one much safer than human driving car. Anyway, the point today is why Tesla models got a huge market share in EV, electrical vehicle industry. Other companies mostly use LiDAR sensor or some laser sensor or some kind of any sensors attached in existing cars. So these are expensive. Of course, they are not that cheap. And you know that if there is a car, okay, this is car, sorry for ugly representation, something like this, and this module or some search scanning device supposed to be placed on top of the roof. How ugly car, take a look. But Tesla, we don't need to place this one because Tesla has amount of just camera, the same camera attached on your smartphones, but many cameras, probably more than 10, 20. Anyway, only image processing, that's exactly Tesla used for this one. Take a look. When this car is driving, this one understands this stop sign, okay? That is why this car can stop in front of that stop sign, okay? And the signal, light signal, yellow signal, red signal, and where's the car parked? Where's the people crossing the street? Where's the car? Behind me or in front of me, and so on. So all these are separate object detection technology enabled. This is really, really critical for autonomous driving vehicle. Okay, Tesla used only cameras, computer visions, image recognition technologies, instead of using those expensive sensors. That is why this one gets some lower price, but very precise and safer detecting results and so on. Because Tesla used exactly same to human eyes. Do you have LiDAR sensor in your brain? Do you have some kind of visual sensors or laser sensors in your eye, retina, your eyeballs? No one has it, right? We only has this kind of visual analysis by your brain. So Tesla resembled. Tesla take advantage exactly same mechanism of a human being. I'm not sure that's the only reason why Tesla got a sort of market leading position in stock price or something, but that's one of them, I think. Also, take a look. I introduce you the Pinterest today. You also know that probably. Pinterest also use object detection. So when you try to find out, for example, Gucci bag or the new from your favorite brand or something, even though users upload their selfies or their fashion images, Pinterest knows what is this one, what is this bag, what is this one, and what is this scarf brand and model and design style and so on. How to detect this object, how to detect this lamp, this couch. They embedded object detection going to reclassify this image. This one can be placed in interior design category and lighting category and couch and so on. And this one's thanks to the antler displayed here. If someone searched some kind of antler applied interior design or some kind of pillows, and then users can find out this image as well. That's the mechanism what Pinterest already applied for. Okay, these are exactly what we looked at this today's class. And as I introduced you today, image recognition is common technology nowadays. Even though this one developed in a couple of years ago and implanted on your smartphone, you already use this one when you are using Facebook, Instagram, Pinterest. But now it's time. So far you were a consumer of such AI technologies. From now, at least in this class, you're supposed to be a creator for AID, okay? So that's going to be your final project subject. Subjects, totally up to you. I'm going to show you specifications for the final project. But anyway, even though you were consumer of such technologies, but take a look. What if we are creators, we are developers, planners for that kind of AI enabled design purpose something? That's going to be your final project, okay? Please take a look at exercise videos and try to make your own code using existing and given code and image training models, so that you can make something totally new and totally better things, okay? For example, cat and dog model, that's exactly what we have done at the beginning of this Google Colab based AID exercises. And we have walked through some chair, armchair cases. And today, probably yesterday, we also Eastern design style versus Western design style. And additionally, Starbucks style versus Blue Bottle style. In the perspective of interior design. So this is deterministic, okay? Cat or dog, that's it. There is no in between. Okay, this is half cat, half dog. There is no such thing because this is general purpose image classification. But how about this one? Sometimes it's controversial. This is intermediate between something classification, something design. How about this one? There is no 100% Blue Bottle style. There is no 100% Starbucks style. All designs have something in between or something combined, something hybrid. So something slightly changed, but that's going to be really huge change in the perspective of AID. Okay, hopefully you can find out something new idea, something new purpose, something totally good for your own project development, hopefully. Okay, and the submission for week 2 is final project plan. Hopefully get your very ideal and very pragmatic and very useful, interesting, exciting final project plan. Hopefully we can get. Thank you.